All right, so today we're going to go over, we're quizzing 9.2 and 9.3, and then we're going to work on 9.4, two sample means that are dependent. Sunday you have Connect Math 9.1, 9.5 due. Next Tuesday you have Connect Math 9.3 due and Lab 7. So don't forget you have a homework due on Sunday. You don't have one due today, but you do have one due on Sunday. So you should get right working on that one. And then next Thursday you have 9.4 due. Your exam is going to be the following Tuesday, the 26th, covering chapters 7 through 9. I have a review session that's coming up Wednesday, and then the following Monday after that. So not this coming Monday, the Monday after that, from 12:30 to 1:30.
So that Wednesday's like the 20th?
Yeah,
Tonight.
yeah, that sounds right. All right, so let's take a look at these things. What we're doing in chapter, what we've done so far is you've done an experiment or you've taken a survey. Why? Either one, you're trying to guess at what the real population mean or population proportion is. So maybe you take a sample, a poll, to figure out who, whether or not you think Hillary Clinton's going to win the election or not. You're trying to get a guess about the whole population. That's chapter 7. Or, and that's going to be called a confidence interval, or let's say estimate. Hypothesis test, chapter 8, is when you know what the general population is, but you have a sort of a subgroup. And you want to know if your subgroup differs somehow from the general population. So you're going to take a sample of your subgroup, compare it to the general population, and see if your sample is really unusual. If it's really unusual, then you could say that your population, your subgroup, must somehow be different than the general population. That's a hypothesis test. Then in chapter 9, we're looking at two different samples, and we're comparing them. So two different kind of populations or subgroups, and we're comparing those two to each other. So that's kind of what we're going to be doing, and or what we've started doing. So we started with two proportions last time. The null hypothesis. Null means no or none, right? So it's always no. In this case, no difference. If there's no difference between the populations, then they're equal. So we have P1 equals P2. P1 does not mean population. P always means proportion. So this is the proportion of the first population is equal to the proportion of the second population. Good? It's also written as the first portion minus the second portion equals 0, because if they're equal, then when you subtract them, you should get 0. No difference. Pooled sample. Remember, we have to have these pooled samples when we have two proportions. And that's when we take the two samples and we mix them into one big sample by taking all the successes from the first sample plus all the successes from the second sample over the n for the first sample size for the first sample plus the sample size for the second sample. That's p bar. Q bar again is 1 minus p bar, pretty typical. Where p is your population proportion, n is your sample size, x is your number of successes. So you have your proportion, your p hat is equal to your x over your n, and also your, if you kind of work this around, you want to find x, you know that n times p hat will give you your x. If you just multiply both sides by n, you get that. So sometimes you're given n and p, and you're trying to find x, and that's how you do it. You need the p hat because the test stat for the two proportions is this. Everything else in the test stays the same, right? The only difference is that your h naught is slightly different. Your critical value stays exactly the same. Your step 4 and your step 5 stays exactly the same. Step 3, figuring out your test stat, is a little bit different. This is the formula. It's still the same idea. It's still your observed value minus your expected value divided by the standard deviation for that sample. So here, if you look on your bottom of your chapter 9 first page, you'll see this, but then you also see that this really is crossed out because that is always equal to 0. We're assuming in the null hypothesis that P1 minus P2 is 0, so we can just look at really this part here. And that's what's at the bottom. Yours is slightly different because yours has taken the P bar, Q bar, and distributed them out of that, so it's in the front. But they're the same thing. You can use either denominator. The denominators are exactly the same. The whole formula is exactly the same. Yeah, Carly.
Wait, on here it says PQ times 1 over M1.
Right, that's what I'm saying.
Oh.
They're exactly the same. All I've done is distribute out the P bar, Q bar.
Oh, okay.
Yep. So you can use either one. They're exactly the same. So don't forget the null hypothesis is that there's no difference between them. Oh wait, why am I repeating myself? Okay, so here's your quiz problem. I will give you guys maybe another 5 minutes now to work on that. So hopefully you have some guidance. Is going to explain what he did. Right? Yes, you are. Brandon, go ahead.
So what I did is I did the first step. I decided to claim. So HL P1 equals P2. H naught.
H naught is H. Yeah.
H naught and H1. P1 is less than P2 is our claim. I found the critical value negative 1.645 because I knew it was left side because it said less likely. So I drew to make a picture, make it easier for myself. Then I found what I needed to find, so I found P hat.
Oh, wait, so I'm sorry. So a couple questions. One, how'd you know the claim was less than?
It says less than.
All right, so you said, oh look here, you said less likely. The claim is less likely. Okay, great. And then, so why is this negative?
Because it's left.
Yeah, so because it's left tail, less than, you know, it has to be that has to be negative. Okay, keep going.
Then I found what I needed to find, so I found P hat 1, then P hat 2.
Which you guys should label P hat 1. P hat 2.
Then I found P bar also. I didn't show how I found Q bar, which you should do by 1 minus 0.438. And I got 0.562.
Okay, seems good.
And then just plugged it into the equation.
This is your test stat,
Yes.
or your T, yeah, it's, you can also call it Z.
Simplified all the way through. Got
Whoa, wait, what's this? Oh, this is the decimal, this is a wrong spot, that's all. Okay,
Simplified all the way through. Got negative 3.462.
oh, wait a second. All right, so this part here, did you add these or did you multiply these?
Add these.
Okay, so
So yeah.
you can't do it like that.
Like that.
It's got to be 1 over 40. Did anybody? So you guys got to pay attention. 1 over 46 plus 1 over 43. That is not the same as 1 over 46 plus 43. What's 1/2 plus 1/2? 1. Everybody on board with that? Mm-hmm. Right? 1/2 plus 1/2 equals 1. 1 over 2 plus 2. What's 1 over 2 plus 2? 1/4. Those are not the same. Right? You can't do it like that. Everybody good with that part? Okay. Good. I'm glad that you guys see. I love the fact that you guys are doing some things because you guys bring up these little tiny things that if we don't see them here because someone has done it without doing anything weird, then you guys will make those mistakes on the exams. Whereas if we see them here, then you guys know not to do them on the exam when it really counts. So, awesome. All right, good deal. So here we've got let's still be right. What did you guys get, what did everybody else get for their test stat?
93.489.
Yeah, negative 3.49.
Okay, so that's pretty close,
Yeah.
right? It's in the same ballpark.
But if I did it with my calculator, I got negative 3.51. So,
Right. So,
drives me nuts.
if you're doing the calculator, that's all right. It'll be close enough. I'm just gonna switch this to a 4.9. Okay, great. All right, so keep going.
Then,
You guys quiet.
since it's inside the theta area, I decided to reject the H naught.
Great.
And then I did step 5, there is enough evidence to support the claims.
Okay, so here's right. So clearly, okay. So first of all, I'm gonna want you guys to make sure you shade this whole area, and then you've got that in there. So that's clearly in the rejection area. It's clearly in the guilty area, right? This is the shaded area is when you consider things unusual, when you're gonna reject them, right? When things are unusual, you reject H naught, because H naught says that you're the same. If you get something unusual, then you say, I'm not the same, and you're going to reject H naught. That's the whole point of this hypothesis test, to see if your sample is unusual or not. So here, you got something unusual, you're going to reject H naught. So, if you reject H naught, then you have enough evidence. Okay, so then we got to figure out whether there's two things that you will toggle between. Enough evidence and whether this is or not enough evidence, and either you're going to support or reject this, depending on what your claim was. If your claim is H naught, you're going to use the word reject. If your claim is H1, you're going to use the word support. If you're still having trouble with that, talk to me later, because I've talked about that like every class for the last 4 classes. I can't keep doing it. Yeah.
Well, I just had a question on the test stat thing. Because in my calculator, I have it all down, but I'm getting negative 2. Not negative.
Yeah, that's not right. So we'll talk about that later.
Okay.
Yeah, Carla?
My question's about the step that 2. Could you show how you calculated this part?
The step 2, that's critical value.
No. How you calculated the bottom part of this test stat.
We can go, while we go through that at the break. Because that's a calculator issue, and it's not something I'm going to pull the whole class into. All right, so the question is, which one was my claim, H naught or H1? H1, so we're always going to use the word support. And remember, step 4 is all about H naught. Only H naught. Reject it or you don't reject it. And it's always reject, never support. You never support H naught. You either find it guilty or not guilty. Either reject it or you don't reject it. Step 5 is always about your claim. You should not have the word H naught in here at all. H naught belongs in step 4, not in step 5. Step 5 is only about the claim. So either you have enough evidence to support the claim or reject the claim. Right? So since H1 was our claim, we're going to use the word support. Because rejecting H naught supports our claim. So that's why we always use the word support. Because we're always going to reject H naught. So always rejecting H naught. If our H1's our claim, then that's always going to support or not support our claim. And then you have to say what the claim is. Support the claim that money in large denominations, do you have to write it out? Yes. Is spent less. Right? Because you're not going to go and share it to friends, hey, guess what? I did a whole, Mom, I did this test today and I found out that I have enough evidence to reject H naught. What? No, I did this whole test. I found out that, that money spent in large denominations is spent less. Right? Something, you got to be able to explain it. Okay. This is just a little blurb about confidence intervals. The basic idea is, again, like everything else, you take what you got from your sample. In this case, we're talking about the differences. So p hat 1 minus p hat 2. plus or minus RE. Those are always confidence intervals. You take what you got, in this case, the p hat 1 minus p hat 2, and you're going to subtract and add your error. In this case, our error is our z alpha over 2. What's z alpha over 2 the same as? In this class we call it our critical value. Look it up in the table. So this is your critical value. And then you multiply it by this part here. I am not going to test you on that part, and you're not going to have any homeworks on it. But I'm going to briefly go over an example. So if we've done a confidence interval about these, the problem you guys just did, you can take a look at that. So here our error would be, again, this is our critical value. The critical value is 1.645, and you plug in your p hat 1, q hat 1, which you guys know your p hat 1 was 12 over 46. So then your q hat 1 would be the 1 minus that, divided by n1, and then here's your p hat 2, 27 over 43, multiplied by your q hat 1 over n2, and you would get an error of 0.161. So then, if you were to add and subtract that, so you're going to take what we got from our, from this part here. So some of you guys did find p hat 1 minus p hat 2, and you got negative 0.367, plus or minus your error, which was 0.161. You'd end up getting negative 0.528 to negative 0.206. What does that mean? It means that when you take p hat 1 and subtract p hat 2, you're going to get always something that's negative. This one doesn't include 0, which means that you can say pretty definitely that p hat 1 is less than p hat 2, because when you subtract them, the range of possibilities is always negative. If you got something positive when you subtract them for this confidence interval, then you could say that p hat 1 is always larger than p hat 2, because when you subtract them and look at the range of your confidence interval possibilities, then it's always positive. If it includes 0, you can't really say either of those. Which is why I really feel like the confidence intervals aren't that useful. You should just do a test. So that's, that's kind of my my feeling about these, because you're comparing two. So when you're comparing, that's kind of how that works. So I'm not going to test you on those or give you guys homeworks on those. But they are in the CID, so we can cover it. Now we're going to talk about the other thing we talked about last class, which is comparing the means of two samples, experimental versus control group, or just two samples. So here, H naught is always going to be that the mu's are equal. So mu1 equals mu2. H1 will either be that they're not equal, or that H1 is greater than, or that H1 is, always be that the two means are equal, or that mu1 is greater than, or that mu1 is less than mu2. Always. Is this on? I hope this is on. Okay, good. All right. So this is means. How do you know a problem's a mean? Let's say mean or average. Or it might be one in disguise where it gives you a list of numbers. All right. Rachel, thanks for volunteering. Go ahead and read.
Lesson the difference between two mean independent samples. Assumption. Both samples are random samples. The samples must be independent of each other. That is, there can be no relationship between the subjects in each sample. If the sample size are less than 30, the populations must be normally or approximately normally distributed.
Right. So independent means you take a sample, and then you randomly take a different sample, and they have nothing to do with each other. The sample sizes. So if your sample sizes are less than 30, I have to tell you, assume the samples are normally, that the populations are normally distributed. I have to tell you that. So that's another clue on your exam that they're normally distributed. Everything on this exam will be, but that may not be true for the final. So So the only other difference again is gonna be in step 3 for these. Here's the formula, which is in your yellow sheet. Everybody should have your yellow sheet out, right? And remember that this part here, again, we're assuming that mu1 is equal to mu2, so that part's equal to 0. So really, it's only this part here that's in your yellow sheet. And remember, this textbook uses, for your degrees of freedom, it's a mean, so you have degrees of freedom, you have a t-table. It uses the smaller of the n's minus 1. So figure out which n is smaller between the two. You have 2 samples, you have 2 n's. Take the smaller one, subtract 1, and use that for your degrees of freedom. That'll be true for all your homework problems in this book. All right, so I'm going to give you guys a minute or 2 to work on proof problem 2. Maybe another 5 minutes. Okay, you guys, listen up. Sierra's going to explain what she did. Sierra, go ahead.
Okay, so I found that H0 was mu1 equals mu2, and H1 was mu1 is greater than mu2.
Why was it greater than?
It says college offer for males is greater than the average number.
Yep. Greater than. There we go.
And then, so I used mean Mr. T for
Nice.
the values, and I found that the critical value equals 1.303, and I used the alpha 0.10 for the table. And then, so for number 3, I did x bar minus x2 over the square root of s1 squared over n1 plus s2 squared over n1, and I found that equaled to 1.029.
Great.
And then I put that on my picture.
So she has it right in there. Great.
And then, so before I said do not reject H0.
Terrific. Why?
There's not enough evidence to support the claim.
Yep. Because it's not in the not guilty range. You can see it from the picture. So as long as you have the picture like this, then you're in good shape. That's your reason why. If you don't have it shaded and don't have these things clearly marked, then you will not get full points for part 4. And I'll say why on your exam. Great. Keep going.
Not enough evidence to support the claim that college offers for males is greater than the average number of sports that colleges offer for females.
Great. Perfect. Good. I'm going to show you guys very briefly. So what I need is this. I don't need this part here, but I absolutely need this part here and this part there. So as long as you put the numbers in the formula, like that, then you can totally just go to your calculator, because those formulas are a little bit of a bear. Do you guys find those being a little bit difficult? So Carlos, something you might want to look at too, is you can just do stat tests. So for this one, what do you think it is? Is it it's one of the 2's? Do you guys agree? There's 2 samples. Do you think it's 2 sample T, 2 sample Z, or 2 prop?
2 samples.
T. It's a mean, it's a T. Everybody good? Then do you have a whole list of data for both of them? No, you have statistics, so you're going to go over there. What was your X1? 8.6. What was your, and then your S1 was 3.3. Your N1 was 50. Your X2 was 7.9. 3.5. Oops, 3.5. And 50. And then your claim was greater than, so it's already on that one. Make sure you click on the one you want and hit enter when you get to it. Pooled, always leave pooled as no. And then hit calculate. So if I wanted not equal to, I just go over to here and enter, and all of a sudden it'd be dark blinking on that one. But I want greater than, so I'm going to go to that one, hit enter, and it'll be blinking on that one. Calculate, and it gives you your test stat, your T right there, 1.03. Good? So that's just a lot simpler to do the calculations part, because the calculations get really complicated with the 2 samples, right? You've got you know, an N1 and N2 and X bar 1 and X bar 2 and S1, S2, you just have a lot of things to deal with. So it's a lot simpler with this one.
Which one do you go to with the proportion?
So, oh, great question. So proportions, we'll look at that one. So what do you guys think? You have two proportions. Is it two sample Z, two sample T, or two prop? Two prop, two proportions. Z test. So go to that one.
So we're only gonna only use those two for these?
What was that?
Those are the only two tests that we use for these?
Yeah.
Okay.
So you're always going to skip the Z test. Always, because the Z's are the ones we don't use, right? It's going to be prop Z instead. Okay, so then the X1 you guys had was 12? Okay, 12 out of 46. And then the other one was 27 out of 43. And then what was your claim, less than? You're going to go to less than, hit enter in that one, and calculate. And remember, CRZ was negative 3.49. So that's what you guys should have gotten from your calculator. Now, here's the thing. I want to take a look at this. If I give you a proportion, like I tell you it's 19% of 27 people, and you end up with 19% of 27 being, I don't know, 5.3 out of 27, and then you go down and calculate, what's going to happen? You're going to get an error, because you can't have 5.3 people, right? So this one assumes that what you give it is the actual number of people. So if you go to the proportions, your X is the number of people, you have to make that, you have to round it to the nearest person, make it 5, right? Whatever the nearest person is, and then you'll be all right. Good? All right. So why don't you guys go ahead and do lab problem 4. I think we didn't do that, correct? All right, so go ahead and do